This Week in Virology, the podcast about viruses, the kind that make you sick. This Week in Virology, episode 35 for May 29th, 2009. From New York City, I'm Vincent Racaniello.
I'm Dick Despommier.
And from Western Massachusetts, I'm Alan Dove.
And joining us today is Rich Kessin, who's a professor here at Columbia. Welcome to TWiV, Rich.
Thank you very much.
Rich is a professor of pathology and cell biology and is an aficionado of microbes, I understand.
That's right, and their history.
Yeah, so we're going to talk about a bit of microbiology history today with Rich. Did you work on microbes at any point in your career?
Well, yes, I did, but if Dictyostelium is kind of a microbe, and that was my truly beloved organism until recently.
Slime mold?
Slime mold, that's right.
But you at one point worked on bacteria?
I at one point worked on T4, and that was a while ago, though.
Phage T4. Excellent. Well, we have a few virology stories before that, but we'll get to talking to you about the history of microbiology. I think that's relevant to viruses, obviously.
Absolutely.
So.
Yeah.
All right, so let's get right into our stories. Just this morning, I received 2 emails which are responsible for our first story. And here, the first email is from Angus, who writes, any chance of a quick primer on J-Lo virus, Lujo virus, in the next episode of TWiV? How is it different from other hemorrhagic viruses, Ebola, Lassa? Where might it have come from? And should people be worried that it was discovered in major cities, Johannesburg and Lusaka, rather than remote villages away from major populations? And then Russ, a bit later, wrote, I thought you should see this story. Scientists identify new lethal virus in Africa. And he provided a link to an AP news story. By the way, I love the show. I'm a practicing dentist and a science geek at heart. Your show allows me to keep up on some topics I may otherwise miss or worse, may have forgotten. Thanks, guys. So here you go, a new arenavirus, Lujo virus, L-U-J-O. We'll post some links to these stories, but basically last fall, we actually talked about this. There was an outbreak of hemorrhagic fever in South Africa, and the agent was not one of the known ones like Lassa fever or Ebola. And so what happened was a guide in...
Zambia.
Thank you, Alan. Zambia. Got sick, and she was airlifted to Johannesburg, I believe. And then she infected 4 other people, healthcare people who were taking care of her. And the first 4 people died, and the 5th survived. They gave the 5th person ribavirin. But they took samples from all these people and gave them to our colleague Ian Lipkin here at Columbia. And within 72 hours, he had a sequence. He'd sequenced all the RNA in these samples, converted to DNA and amplified it and sequenced it, and found a new arenavirus in these samples.
Wow.
And this is totally different from all the known old and new world arenaviruses. Arenaviruses include Lassa, which is an old world because it came from...
Lassa, Nigeria.
That's right, Africa. And there's another one, lymphocytic choriomeningitis virus is another well-known arenavirus. But this is different by sequence from all of them. It seems to be a new virus in this family. And one of our emails said, how does it differ from Ebola and Lassa? Well, Ebola is in a different family entirely. It's the filovirus family.
Right.
So this is arenavirus, and so it's brand new, and it shows that you can use sequencing to identify really quickly new viruses.
Vince, is this a rodent-transmitted virus?
Well, what a good question. You know, most of them are.
Yeah.
Right? Their reservoir, at least,
right.
This seems to be rodents.
And urine. It's the urine, actually.
So it's urine, feces.
That's right.
Or if you eat rodents that are infected, you would get infected as well. So we don't know how this person got infected. So one of the emails said, should we be worried that it was in a major city? Well, it's only they brought her to a major city, so I think she was a guide and probably was bringing people around in the countryside, right?
Well, it reminds me of an outbreak that we had here in Queens. We had one case of death from hantavirus. Mm-hmm. So should we be worried about every mouse and rat in New York City because of that one death? And the answer is no.
No. Did that hanta originate from a rodent in New York?
It's on Long Island, I think.
Yeah, it was on Long Island in some warehouse. It was an Asian gentleman who actually caught it and died.
I mean, the question is whether they ever found hanta in rodents on Long Island is Do you know?
No, I don't.
I don't know. So this virus has never been found in any rodent anywhere, but it must exist somewhere.
Right.
And it now has jumped into people. You know, there's more contact between people and rodents. But also we're being very aggressive with diagnosis, right? We get these samples, bing, we sequence them in 72 hours, we have the virus. So I wouldn't worry that it was this person was brought to a city, so I don't think that's a worry. And I'm sure she got it in a remote area.
Well, the biggest worry was those 4 people that came in contact with her. They also caught it. So that is the biggest part of the worry, I think.
Right. Although it appears that as soon as they implemented barrier precautions in the hospital, that stopped happening. They didn't get any additional cases.
But remember what happened with SARS.
Right.
That continued to spread, even though they did have good barrier medicine, but they weren't burying against the right thing.
Yeah, it just is unfortunate that someone comes in with hemorrhagic fever that they don't immediately say, oh, this could be an infectious agent. And because those 4 people don't have to get sick. I think one of the people was cleaning the floor of the room where the person had been and got sick from some body fluids, obviously. So this just came out in PLOS, and now that we have the sequence, of course, we can make reagents to diagnose this really quickly. So we'll see what animals it's in. You know, the problem here is that you can't look for viruses in every animal.
Why not? You can look for them in every animal. No, you can look for them in every animal group because there's a huge amount of serum banked away from the zoos of the world and from the wildlife collectors. So I think you could do it, actually. I think you could.
Yeah, well, I think money is an issue and also people.
Yeah, how much do you want to know? That's true.
I agree with you that we should look a lot more than we are.
Yeah.
And now, for example, we're looking more in pigs than we ever did, right?
Well, listen to this, Vince. The human genome in another 10 years will be completely sequenceable for about $1,000.
In a day, right?
That's incredible.
I know.
Come on, that's incredible. If that's true, then we can survey. Come on, we can do this.
Well, I think clearly here they need to look for this virus just to see where it came from.
Absolutely.
It turns out that I believe one arenavirus does have a bat reservoir.
Yeah.
And this one appears to, just from the sequence, it looks like this is something that's been around, that originated a while ago. They're talking about the glycoprotein sequence that's almost equidistant from old world and new world arenaviruses. So this is not just some small branch that came off yesterday. This is something that's been probably circulating in whatever its reservoir host is for quite some time.
Sure. Yeah, no, that's a good point. It's in fact, it's a branch, it's an ancestral branch on the phylogenetic tree that you can make from the sequences of all these viruses. It's quite old, so it's probably been around for a while. We just haven't picked it up. And you know what? There are probably others like it.
Sure.
And novel, and we haven't picked them up yet.
Exactly.
So anyway, that's very interesting. That's our first story. And before we move on to other stories, let's talk about influenza a bit. The current caseload as of 27th May, that's 2 days ago. Let's see if we can get a more recent number.
I thought I saw something today from WHO.
WHO 27th May is the last outbreak. Let's see if there's one. 28th May. Here, no, that's Egypt. H5N1 in Egypt. Yeah. Been a couple of deaths from H5N1 avian influenza in Egypt. 2 days ago, 14,000 cases globally, 95 deaths. It's obviously more, and it's obviously been increasing steadily. Yep. And it's probably 10 times more than that in actual cases.
Right.
I mean, so probably there are.
But the vast majority are in Mexico and the United States.
So far, Mexico 4,500 cases, the U.S. 6,700. Nobody comes close to that. Yeah. Which may be an issue of surveillance also, right?
Could be.
But South America now has a lot of cases. Argentina, Chile, Peru, Colombia, many cases. Australia has a lot now. So it's starting to ramp up in the southern hemisphere, as we had predicted, and as you would predict. And the U.S., the CDC says it's waning. But interestingly, there are some people who don't think that it is. In fact, I think in New York and Boston, there seem to be a lot of cases still being identified.
And in New Jersey.
In New Jersey as well?
Yep.
So the CDC national data show the graph going down for influenza isolations. But if you look in cities like New York, Boston, you see it's not. And in fact, there's a website, the International Society for Disease Surveillance has a website where they look at influenza-like illness, all these illnesses that are reported. And not just the confirmed cases, which is what the CDC does. They look at all the influenza-like illness. And the fellow who runs this, Donald Olson, a New York City-based epidemiologist. You don't happen to know this fellow, do you?
Sorry, I don't.
He says New York City, Boston, and Seattle, it's still going up. And he has a lot of interesting graphs on his website which show the data not decreasing everywhere. So there's a little bit of controversy over whether it's in fact going down or not in the U.S. My feeling is it will disappear soon in the U.S. It won't go, I shouldn't say disappear. It'll reduce. It's not going to be an epidemic over the summer. I would be really surprised if that happened. I think in the southern hemisphere it will continue to increase. But here, I think we're almost done.
Is the initially high level of deaths reported from Mexico being maintained in the recent cases from Mexico?
Not at all, no. Well, the Mexican epidemic's pretty much over, and that's peaked, and there's no more deaths. There have been deaths elsewhere, but not. The key with Mexico is that initially there were a lot of cases, and that's why there were so many deaths. About 0.4% mortality, which is not much higher than seasonal flu. And elsewhere now in the rest of the world, it's about that as well. So the only reason there were so many, which is what scared a lot of people initially, is that there were so many cases. More than we thought, actually. Okay, anything else on flu that we should mention before we leave the stats?
It's just about the vaccine development.
Yes. Several vaccine candidates have now been released by CDC and WHO. So these are high-yielding virus recombinants that you use to grow in eggs. So those have been prepared and actually Dr. Doris Bucher, who's up at New York Medical College, prepares the high-yielding recombinant. They have the surface glycoproteins of the new strain and everything else from a high-yielding egg virus. So companies can now have that and make a vaccine. You could get that virus, Dick, and make a vaccine if you wanted.
I could do that in my spare time.
CDC would send it to you.
They would do it.
But you would have to make sure that prevent yourself from being sued when people have bad reactions to it. So that's a problem. Okay, we're going to have a couple of other stories before we move on. But first, a word from our friends at Citrix, the makers of GoToMyPC. And, you know, we've talked a lot about GoToMyPC on TWiV, and you know that I use it and I highly recommend it. It's a way of remotely accessing your computer from another computer. And we've told you that you can have a free trial, but maybe you haven't tried it because it sounds complicated.
Is it?
Well, let me assure you, it's easy to set up and easy to use. What you do, first you sign up for a free trial. You go to GoToMyPC.com/podcast. You get a free trial. You make sure you're at the computer you want to access. You click download, and it sets up automatically. It takes just 2 minutes. Then, from any other computer, you log on to GoToMyPC.com with your secure password, and you click the connect button, and you have full access to your computer, all your files, your email, your network, anything you want, from anywhere in the world. It's very simple and very secure.
Maybe their slogan should be, "It just works."
It just works.
Taken.
Yes.
Or just do it.
Just do it. In any case, it is simple, it is secure, and it does work. So you can try GoToMyPC free for 30 days, but you must visit GoToMyPC.com/podcast. That's GoToMyPC.com/podcast for a free 30-day trial. Tell them TWiV sent you. I thought it was interesting to read in the past week. There was a New York Times article, perhaps some of you have seen this, entitled WHO to Rewrite Its Pandemic Rules. They basically decided that there was too much excitement over this current H1N1. It's not lethal enough, and they got people too excited, and they shouldn't have done that.
And so did the press, by the way.
Also depressed, yeah?
No, the press did that too.
The press did it.
They hyped this story right up into the front page.
Well, cool. On a daily basis. There's always a story every day, multiple stories.
You're right.
So, according to this article, it would rewrite its rules for alerting the world to new diseases, meaning the swine flu circling the globe will probably never be declared a full-fledged pandemic.
Correct.
This is ridiculous in my view, because a pandemic is a pandemic.
Yeah, but it's...
A pandemic simply means global epidemic, right?
But it's a loaded word at this point.
It's got
that's
emotional
true.
connotations.
When did it get loaded, Alan?
Probably about the time it entered common use. Because pandemic automatically, I mean, as a term of art among epidemiologists, you know, a pandemic is just an epidemic that's spread to multiple countries. Right. But when that goes into a news story, people get the suffix of it, and they say, oh, a pandemic, that must be worse than an epidemic. And so this word then becomes, it's like the really, really bad version of an epidemic.
Right.
And that, of course, has nothing to do with the actual pathogenesis of the disease. We've got a pandemic of CMV around the world.
And cholera, come on, we've got some killers out there too.
Oh, sure, and we've got some really, really bad stuff out there that's in pandemic form.
Right? So, my opinion, the hype started when the H5N1 virus appeared on the scene, and people were fearful that it would become pandemic, but it had not become pandemic.
Yes.
So they said, this has the potential for pandemicity. And that's crap. That's absolute crap. You have to wait for it.
I think that's right. The bird flu began it. Because before that, it was just an epidemiological term that scientists used, and we used it properly.
So you remember what I said about this on one of our TWiV shows.
What did you say?
I said it was much achoo about nothing.
Much achoo about nothing, that's right.
Well, there are other bad words circulating now.
I love the photo that goes with this Times article.
Oh, yes. I don't know,
Japanese school kids. And
Japanese school kids.
But that's the way they go to class every day. Come on, that doesn't count.
Well, no, what I love about it is that half of them have their masks like off their faces part way, or their noses exposed. And it's just a perfect demonstration of how these types of things get implemented.
Oh, well.
Yes. What were you going to say, Rich?
Well, there's another bad word circulating, and that's swine.
Exactly right.
You get the combination of swine and pandemic.
That's right.
And you've got the square of fear.
Yeah, remember, though, when they first started, they were calling it the Mexican swine flu, and they've to drop that now, too.
Yes.
But we still refer to the other one as the Spanish flu, and I'm not sure that's justified either.
Not at all. It didn't originate there.
No, of course not.
But I think that pandemic has a definition, a scientific epidemiological definition. It can't be changed. If WHO wants to change their alert process, that's fine, but they can't use the word pandemic. They have to use something else.
No, what they should do is qualify the nature of the disease that's pandemic. They should qualify it and say, this is normal flu. They're going to have a 0.4% death rate, but it's in multiple countries. So, yes, it's a pandemic, but it's not anything more to worry about than last year's flu.
Well, I posted this on my blog, and I got a lot of very vehement opposition to redefining pandemic. It was very interesting.
Okay.
It was very nice to know. But I think they can do it, but they can't change the meaning of pandemic, which is global epidemic. They can change their alert criteria.
Yeah, they have to put a color on this, like orange or yellow, like we do for domestic.
Well, the people who control this word.
To be so useful, yes.
I'm getting tired of the color orange, by the way. I don't know about you guys, but
Much achoo about nothing. That'll be the title of this episode. What do you think?
achoo about nothing. I think I would like that, actually.
I like that too.
Yeah.
Two more things. First, when we were live in Philadelphia, we talked a lot about an adjuvant, but we never said what it was. Someone afterwards said, "What's an adjuvant?" Do you think everyone knows what that is?
It's like an adjutant. No, it's not. No. We won't go there.
An adjuvant. Dick, do you want to define an
sure,
adjuvant?
Sure. Well, I actually in my past life as a laboratory scientist, I did a lot of work on immunization of animals to a larger organism than a virus. It's called Trichinella, but I still had to worry about how I would deliver the antigen. Would I just inject it into the animal raw, or would I mix it with something to make it last longer so there would be a slower release process of the antigen to make sure that all the B cell subsets got stimulated and I got a full, robust immune response. So I think what we've found out over time is that it's best to place an antigen in a substance or a combination of substances which will cause its slow release and uptake by the macrophages and then through the cascading effects of making antibodies and or even in stimulating cell responses as well that are not antibody based.
What adjuvant did you use for that?
I used freunds.
Freunds, the famous Freunds Complete.
Freunds Incomplete and Complete.
So incomplete is just mineral oil.
And
complete is mineral oil plus killed tubercle bacilli.
This is correct.
Tuberculosis bacilli. And
that's right.
We now know that this is actually an immunostimulant. It stimulates the innate response to help get a better antibody response.
Exactly.
And this is not licensed for use in people, as you know, Freunds, because it gives a very bad skin rash.
But there is an adjuvant that is licensed for use in people, and that is?
Alum.
Exactly.
This is used in a couple of human vaccines, and it allows you to not only use less virus, but to get a better immune response. So it's something you add to the vaccine. And Charles Janeway called them The immunologist's dirty little secret, adjuvants.
I prefer to think of them as the special sauce in vaccines.
Special sauce, yeah, that's a good one too.
That's true.
So we were talking about this at TWiV Live in the context of some of the new flu vaccines being made, I think by Glaxo. They are planning to include an adjuvant.
It's a proprietary adjuvant.
It's proprietary, so we don't know what it is.
Yeah.
And it's not licensed by the FDA. But now, just last week, HHS said that they were going to spend some money on determining whether this was safe or not.
Right. So there are two other approaches, by the way, as long as we're on the process of how to immunize, which I think are worth mentioning. One is you could have a temperature-sensitive mutant of your organism, and then you can inject it under the skin. So the temperature sensitivity is that when it reaches a higher temperature, it's killed. When it remains at lower temperature, it's still alive. So you can have a pool of live organisms under the skin constantly stimulating the immune response, as long as you don't get cellular damage to the effect of something called an ulcer that you might get from this. So there is a temperature-sensitive mutant for Toxoplasma gondii to immunize cats. And it was selected by Elmer Pfefferkorn up at Dartmouth, and it was a very clever mutant, because the cat has a temperature sensitivity that's differential. And you can inject this under the skin as a live organism. But it never causes a full-blown infection, because once it reaches the higher core temperature, it dies.
So that's actually used in a... So there is a flu vaccine called Flu Mist. I don't know if you've heard of this, which you inhale.
It's an oral,
You inhale it.
Okay.
And this is actually a cold-adapted virus, because the upper tract has a lower temperature than the lower tract. So that virus grows pretty well in the upper tract. It immunizes you, but if it happens to get down into the lower tract, it doesn't grow because it's temperature sensitive.
Okay, and the other approach is a DNA virus, a DNA vaccine.
DNA vaccines.
Yeah, DNA vaccines.
Yeah, injecting DNA, absolutely. Exactly. Okay, that's an adjuvant. Now, Dick, you sent me a couple of very interesting papers.
I did. For once, I actually came up with something intellectually.
Diseases. And in fact, one of them is I looked at is in Nature.
Yep.
2007, but still relevant, by Jared Diamond.
Exactly.
Origins of Major Human Infectious Diseases.
Yeah.
And this is very interesting. It starts out, many of the major human infectious diseases, including some now confined to humans and absent from animals, are new ones that arose only after the origins of agriculture.
Right.
And so this article tries to understand where they came from, why are they mostly from the old world, and where are they going? Did you know that the term emerging virus was coined by Steve Morse?
I do.
Yes, we confirmed that last week.
In fact, Steve and I teach a course together, and that's how I found that out.
So they have some very nice illustrations in this paper. The 5 stages through which pathogens of animals evolved to cause diseases confined to humans, which every listener of TWiV should have a look at. We're going to post this in the show notes. Who is Jared Diamond?
You know, I've actually met this gentleman, and I can tell you that this is one of the most versatile intellectual people I have ever met. I saw him at Harvard giving 2 separate lectures. He was at UCLA at the time. He still is. They were recruiting him back to Harvard because that's where he got his degrees. He has 1 degree in inorganic chemistry. He has another interest and high degree in bowerbird behavior in Papua New Guinea. So he's got these 2 completely separate subjects. He's an anthropology type person as well. And he's written this book, Collapse, which is all about how civilizations wax and wane because of the fact that they exceed their limits for resources. And here he is writing an article about the origins of infectious diseases, but he's relating it back to the origins of agriculture, which is an anthropological touchstone for a lot of things that plague the earth today and what we're trying to deal with. He's a fantastic
Didn't he
lecturer.
write a book about guns and...
Guns and steel, yeah.
Guns, steel, and germs.
And germs,
right.
Germs.
It's a marvelous read.
Okay.
His book Collapse was a little bit collapsed. It sort of had a one-theme approach that then developed into 14 different reasons why a civilization would collapse. But I think he had all the right reasons. It was just a little complicated, that's all. But he's a marvelous thinker and very clear and right on the money.
Why are these infectious diseases of old world origin? Do you know?
I guess because we've been there longer. That's where we all came from, Vince. I don't know about your ancestors, but mine all came from the old world, not the new world. I'm not a Native American, so I can't honestly say that I belong here.
Of course, today we don't only have old world emergence of new pathogens. They're from all over the place.
But here's something interesting that he said once in a lecture that I heard was that we have never domesticated an animal that was native to Africa.
I'll have to take his word because offhand
What about the camel? Where does that come from?
That comes from the Middle East.
Yeah, Middle East.
The horse comes from Asia, the chicken and the cow and the donkey, the pig, the horse, I said that already, the cat, the dog. None of those animals come from Africa.
Why is that? Do you know?
No, but he speculates that the selective pressures for domestication in a country or a region which has huge numbers of predator animals forces those animals to develop certain skills that you can't breed that out of them. They'll always be aggressive and run away from things, and they're not. Even the African elephant has never been domesticated to any great degree. The Asian elephants have, but it's all predator related, I think.
Have I been watching too many movies, or can you domesticate a zebra?
You
cannot.
You can't do it. No, you can't. You can't.
Right, have you seen?
They've tried.
What movie did you see a pet zebra in?
I've seen. I can't
The
remember.
Lion King.
Perhaps, yeah.
No, I used to know a zookeeper
Point well taken, right?
Who commented that zebras are some of the nastiest animals you can possibly work with. They're apparently really, really horrible.
I can attest to that because when I was in Africa, the only part of the zebra we ever got to see was the rear end. That's what they would point at the tourists all the time. No, that's just a... But it's true, by the way.
Anyway, we'll put that paper in our links. It's a great one. I like it very much. Good. Before we go on to the history of microbiology with Rich, we will have a short message from our friends at the American Society for Microbiology.
Now available in 2 conveniently sized volumes, Principles of Virology 3rd edition is completely revised and updated to reflect important advances in the field. This textbook continues to fill the gap between introductory text and advanced reviews of major virus families. 2 volumes provide upper-level undergraduate students, graduate students, and medical students with a state-of-the-art introduction to all aspects of virology. Visit ASM Press at estore.asm.org to view sample chapters and the complete table of contents. Request your examination copy today at estore.asm.org.
Vince, who wrote that book?
4 virologists.
Really?
Flint, Enquist, Scalca, and Racaniello.
My goodness.
Yeah, one of your hosts here at TWiV.
Congratulations.
So take a look if you want to learn about virology. You can get an evaluation copy, apparently. Rich, how did you get interested in the history of microbiology?
Well, at first I got interested in the history of history. And I was a history major in college as well as a biology major, and I guess some things bite you and you don't get over it.
And then you went from being a history major to getting a PhD in science, right?
That's right.
And then that you
probably a mistake, but
you should have stayed in history.
Possibly. Who knows? It's a little late.
So when does microbiology begin, as far as you can tell?
Oh, it's very hard to put a date on this thing. I mean, it's a little arbitrary, and historians argue about that. But let's choose one for our purposes. Let's choose Leeuwenhoek in the 1680s, who had the first really good microscope. His microscope was just a single spherical lens,
right,
and it had no aberration to it, which the other guy at the time was Hooke. He looked at the teeth, the stuff from your teeth. And he would look at it there, and he described these things. And he didn't speak any English. He just wrote in Dutch, but he had people translate it. And it all got sent in this very sort of anecdotal fashion to the Royal Society, which had just started in London, and where Hooke was the secretary. He described in this goo from people's teeth. He even found some guys who never brushed their teeth, so that was a really good source. And things that darted around, that swam in a straight line and then tumbled. And those of us who study bacteria know that that's a dead ringer for chemotaxis and movement in bacteria. So that would be probably as good a starting date as any. It's coincident with the microscope, of course.
Right. He also discovered Giardia.
Is that right?
Yeah, we've talked about this before.
But he didn't know it was Giardia. He just knew.
He described it as Giardia.
Is that right?
Yeah. No, he had no clue about that these things would cause disease.
No, I didn't say that's true. That's absolutely right.
But he called it Giardia.
Yeah, it was in his own stool.
Yeah. Well, the guy would look at he looked at his own sperm. I mean, Well,
if you can see microbes, why
curious.
not? So, but no one knew what this meant, right?
No.
Yeah, no. There was no association of bacteria with disease for 200 years.
Now, you could actually go further back for the origins of microbiology, right? I mean, in some sense, it's maybe the second oldest profession, right? Brewing, I'm thinking of.
Yeah, but you didn't know.
Yeah.
People
You didn't know what the active ingredient was.
That's right.
Yes.
It was just called the ferment, and we maintained the word, but we don't.
Yeah.
Or at least we did. But we didn't know that it was a biological entity until until 1837. Well, three people discovered it at that time, and they were widely derided. And
what about the Greeks, Rich? What were they saying about diseases?
they believed in more or less the miasma theory, that it was just some bad eminence, some emission from the earth. They were called telluric influences later on, and they went well into the 19th century, that would cause these diseases.
And then malaria?
That's right, just bad air. It's the same sort.
Is that right?
Thing.
Yeah, that's the source of the name malaria.
Oh, sure.
Exactly right.
Yeah.
And dis-ease.
Yeah.
Well, in fact, one of the early discoveries with malaria was that you could filter out the bad air with cotton screens on your windows. You were less likely to get the disease if you filtered the air that way.
Sure.
Or if you filled in the swamps like they did in Ostia.
Yes.
Right. I mean, there were various medieval villages in Italy that would build moats to protect themselves, and then everybody would get sick from the mosquitoes.
Pestum. Do you know this? The town of Pestum in Italy was destroyed many, many years ago. It was a Greek settlement in Italy that was destroyed probably by malaria.
I'll be darned. Or plague.
And they called it Pestum as a result.
Neat.
Yeah, or plague, maybe, yeah.
And were the people who lived there pests?
They were. 200 years, you said 1837. What happened?
Well, no, I mean, in 1837, there were three guys. Sorry to be so detailed, but one of them was Schwann of cell fame, who looked at, and there was another guy named Cagnière Latour, and I forget the third one, who looked in beer, essentially, and they saw budding yeast the way you still would. Yeast is kind of unmistakable, and it's larger than bacteria. And they described these things, and they said it consumes the medium to grow. Right. Which is what we would do, anything nowadays. And the chemists of the time, German chemists and Swedish Berzelius and Liebig, they just derided these guys as an insult to that it was vitalism, that it was just confounding the emerging sense of science and capacity of science to explain things. And this was a debate that went on and on and on until finally Pasteur, sort of wielding the jawbone of an ass, laid these guys low.
What about the Chinese, though, in the scarification with regards to smallpox amelioration? That was some belief that you were taking something from one person and giving it to somebody else. That was a long, long time before what you just described.
That's true, and it happened. It came to Europe, as I recall, through Turkey, where there was a British ambassador in Turkey, and it's actually his wife, Lady Montagu, as I recall. Smallpox was a terrible scourge. It would kill a huge percentage of the population in the most ghastly way. And she figured out that, well, maybe they brought this back to England, and they would take a little scab, and they would inject it into someone, and you'd either get a mild reaction or a bad reaction. And I don't know if you saw the recent thing with John Adams, right? There was an episode in that. It was
a great scene.
It was a great scene, and some people came out okay, and some did not. It was a pretty disastrous, could be a disastrous thing, but the risks of the disease were so great that it was done. And Ben Franklin was one of the great...
And Jenner was involved in all this, too.
Yeah, well, Jenner came in the 1890s.
Oh, okay.
And, he's accused of sort of abusing his patients, but he made this fundamental observation that milkmaids, of course, this is a clock...
1790s?
1790s, right.
1790s.
1790s.
Before Pasteur.
Oh, long before
Absolutely.
Pasteur. And although Pasteur knew about this, and we'll come to that, but he... noticed that these milkmaids never got smallpox, which meant, of course, that there had to be a huge level of smallpox for him to notice this against the background. And he did this experiment where he took the cowpox and he injected a young boy, 10 or 11 years old. And then people casually say he injected the kid with smallpox. and he was immune. But I don't think it was the smallpox, and I have the book, and I should look this up. I think it was the scarification that Dixon was just talking about.
Right.
So that
His IRB never would have approved it.
No IRB would have approved any of these experiments in the 19th century.
This is all true.
I mean, that's for sure. And but Jenner became a great hero, and it was a much safer procedure than the scarification. So he became a great hero. Even Napoleon, who was the arch enemy of the British a few years later, honored him in some great way. He gave him free passage throughout Europe during the Napoleonic Wars.
So, are you familiar with the story in the U.S. when the data reached Philadelphia? I guess maybe through Franklin's travels, that there was a cure for smallpox or prevention for smallpox. A banker with 6 sons to champion Jenner's idea in the United States took 3 of his sons and had them immunized, and the other 3 not. And then the next time there was an outbreak, he took them to the hospital.
No,
is that a heretical story?
It's heretical, and I think it's probably also apocryphal. I have not heard that story.
Elvin Cabot, who taught at this university for many, many years, used to tell us that story.
But wait a minute now. Franklin died before Jenner, right?
Mm-hmm. Did he?
Jenner was 1890, middle 1890s.
No, you said 1790s.
1790s, I'm sorry. And so
they were contemporary. Franklin was certainly around.
Sure, they were around at the same time. They had to be around.
Well, when did Franklin die? He was a very old man at the Constitutional Convention, right? Which is 1783.
Right.
And I don't know how far he made it into the 1790s.
Wait a minute. We can go to the internet and find this out instantly.
The process of looking
this
up.
Just Google it.
He died April 17th, 1790.
Right. So that was.
And Jenner
was a few years later, I believe, but I have not checked that out.
Well, forget Franklin then. It wasn't him at all.
Yeah, so
but it was some banker in Philadelphia, though.
I can't scientifically say, Dixon, that story is wrong.
Jenner was 1823. He died, so he was a bit later.
I heard this story from Elvin Cabot, so I'm sure that.
Elvin was a good storyteller.
He was a great storyteller.
It's a shame to waste a good story.
That's true.
So how do we get Pasteur into this story?
Well, so if you go back to those yeast guys, Racaniello and Schwann, who were ridiculed by the German chemists, Pasteur was a chemist, and he was a kid, and he was just this prodigy. He came out of nowhere. And he went to the École Normale, which was the top school in France, founded during the Revolution to educate the kids, the sons, always the sons at this time, of, that were to go into the teaching professions. And he had a mentor, which is always essential in science, I think. And the guy's name was Biot, and B-I-O-T. And he invented the polarimeter. So you could take polarized light, and he would put some natural substance, strychnine was a favorite, I think, in it, and that would just rotate the light to the right. And it was a big mystery. And when
tartaric acid.
Well, that's when.
Did I spoil that story? I'm sorry.
Yes, you did. And
okay, you can do this again. Come on, we don't.
When Pasteur came to his lab, he says there's this tartaric acid stuff, and there's this big mystery. And that I was talking to Vinny about this yesterday, and that was that there are 2 forms. It's the sludge that forms in red wine that you see in the bottom of a red wine barrel. And it makes wonderful crystals, but you can get it either from wine or you can make it chemically, which was long known. And chemically, the crystallization purified the stuff, and then you dissolved it. And chemically, a very famous German chemist named Mixterlich showed that those things were identical, but the problem was the same number of carbons and hydrogens and whatever. And this problem was that the wine tartrate rotated things to the right, and the chemical tartrate did not. And that was true of a lot of other compounds. And this drove chemistry crazy because they realized that they didn't understand something very fundamental. And Pasteur was assigned to do this, and he looked at these crystals from wine, and he looked and he looked and he looked. And finally, I guess he wasn't dyslexic or anything, because he could see that they were mirror images, like two gloves. And he patiently sorted these things under the microscope and dissolved them both. And then one rotated to the right and the other one to the left. You mixed them together. They didn't rotate anymore. So that was it was some indication that there was something fundamental in the structure of a molecule other than its chemical composition that could vary. And of course, we now know it's chirality. It's the first thing you learn in organic chemistry. Maybe the only thing I remember from organic chemistry. And he discovered this, and he became, at this point, he was famous. The revolution. It was during the Revolution of 1848, so all hell was breaking loose on the streets, and he was up there sorting these crystals, right? So he had a capacity for concentration that was amazing. And at this point, he went to this fancy school, and they were supposed to make teachers, and he was a poor boy. His father was a tanner, and so the Minister of Education decides he's going to go teach in some school in, I forget, some small provincial town. And he did. He had a ship out for this town, and he taught there only for a few months until his patrons in Paris rescued him and sent him to Strasbourg, where he joined a real faculty. And there he married the boss's daughter, the rector's daughter. It's always a good strategy, at least in the 19th century. And
Darwin learned that lesson too.
Darwin and Lister and all.
That's right.
Yeah. And nowadays you have. You could marry the son, I suppose. But in any case, in those days, he got to be a pretty solid chemist, and he went on with this chirality stuff. But when he was next sent to Lille, which is in the north of France, and it's a big beet growing region, and they take the beets and they would make sugar. They're full of sugar, and they'd extract them, and then they would ferment. They didn't know they were fermenting, but they would ferment the sugar. And to make ethanol. And from ethanol, they'd make ether, and also it's a good starting point. And Pasteur had a student in one of his classes, which were very practical. He had the first lab class in France. And with a student whose name was Beagle. And he said, my father's having trouble in his factory, in his beet factory. He's got this ghastly, smelly stuff that's not making any alcohol. Can you come and look? So Pasteur just moved into the factory. He made a little lab. And we have a letter from his wife saying he's up to his neck in beet juice. And he looks, he isolated the chemical, and sure enough, it rotated light to the right, and everything else that did that came from a living source. So he figured there was something living in the contaminated cultures that was different from what was in the good cultures. The good vats of fermentation vats. And sure enough, in the good ones there was yeast, good old Saccharomyces, and in the bad ones there was some bacterium, a coccus that was very small, and he saw it under the microscope. And he said to Mr. Bugo, well, here's what we're going to do. We're going to wash the beets, and we're going to heat them to kill the bacteria that comes with the dirt or whatever. And then we're going to dump a ton of yeast in there, and you'll get ethanol. And sure enough.
But did he say kill the bacteria by heating? Did he know that at that point?
Yes. He had figured out that you could kill stuff. I actually...
There should be a name for that procedure.
Well, yes, there is. It's called...
Probably named after the inventor, but who...
Pasteurization was actually in the future. But actually, if I think about reading the papers, I don't think he actually says heat. Mm-hmm. But I think that, he would... If you want to... that may have been part of the process anyway. There's not a lot of detail in Pasteur's papers. You're going to mash up the yeast, the beets, and throw something in like the yeast, and it will metabolize. But the fact of the matter is, there weren't supposed to be anything other than the yeast in there. And if there were, and this happened over and over and over again in the beer industry and everything, he could tell that something was wrong, and he would just tell them to start all over again. And it's a question of a pure culture. Which he himself did not always have, but that's a later story.
So, Rich, wasn't there also a connection here with the argument about spontaneous generation?
Right. So. He at that time, so you have the idea that microorganisms are essential for fermentation, and that furthermore they create these chiral molecules that rotate polarized light. Right. And wherever you find some product that rotates polarized light, that had to be, according to Pasteur, and this was the great leap that he made, there had to be some living thing there. And either whether it was the right thing or the wrong thing, but it was definitely a biological fermentation. And the prevailing thought since antiquity had been that organisms just generate spontaneously, even mice. Or Aristotle thought that eels came from the muck in the bottom of rivers and such. And that
they did as eggs.
Yeah, and that was a debate that had gone on for hundreds of years. There were these great Italian scientists, Redi and Spallanzani, who people thought that maggots came out of meat, but they simply Redi did anyway, put a screen over the meat and found that no maggots appeared, so that it became. Spallanzani was a genius. He had all sorts of other wonderful things. He worked on bats. That was great. Put tinfoil over their eyes and let them fly around, and they avoided everything, and the people of the town thought he was some sort of weirdo and drummed him out of town. But this debate had gone on for a long time. But, if bacteria could form from anything, it would be very hard to eliminate them from a fermentation vat, an operating field,
or a flask.
And Pasteur realized a few years later, in the late 1850s, that this idea, which had at that point been driven down to microorganisms, had to go. And he had, one of the things that characterizes this man's career is that throughout it he had a series of enemies, sort of straw men who he did battle with. And he was very articulate, he was very sure of himself, and he did not suffer fools. And his big opponent at the time was a guy named Gabriel Pouchet, who was a naturalist, and he was the head of a natural history museum.
I would call him an unnaturalist.
Well, I mean, history tells us that you're not supposed to diss people of the 19th century for not being people of the 21st, but, I think Pouchet was kind of a fool in any century. And he got into this big battle with Pouchet, and they had these dueling experiments. Pouchet was a member of the Academy, so he could get published anytime he wanted, like sort of publishing in PNAS, I suppose. And
touche.
And they had this fight, and Pouchet tended toward these very Baroque experiments, and Pasteur toward very simple ones, which you will see in Vinny's book if you buy it. And they fought it out, and eventually Pasteur invented the swan-neck flasks, and he studied bacteria caught in cotton, and he came to the idea that bacteria were everywhere in the atmosphere and predominantly carried on dust, which is true. And they did all these wonderful experiments where he would make flasks of basically what we would now call almost LB, and he would seal them sterilely, and he'd climb to the top of he'd either open them in Paris and show that, and then reseal them, and they'd get contaminated, and he'd also take them to the Mer de Glace, which was a big glacier in the Alps, and open them and reseal them, and they wouldn't get contaminated. And Pouchet had his different medium. Pouchet had a medium that he made out of boiled hay, and he was a pretty good competitor, and if Pasteur climbed to one glacier, Pouchet and his buddies climbed to a higher glacier and did this. But their flasks, if they opened them, still always got contaminated. And it was a big mystery, and Pasteur basically had contempt for them. And one day in April of 1864, there was a whole series of long papers on this. And microbiology can't proceed until you've settled this issue. It was like chemistry with the tartrate, because if any bacteria came from anywhere, then there was no defense against them. And so in 1864, he had this big evening. He was a big showman. And he rented a hall, or he was given a hall at the Sorbonne, which is still there. And he basically went through all of the history of Pasteur papers are characterized by this huge historical section where he knew everything. No medline, no nothing. And he just went through this, and you'd think in 1864 that you could not project slides on the wall for the audience, which was the good and great
daguerreotypes.
Yeah, the good and great of Paris. There was Georges Sand, famous writer, and all sorts of people. And he did that, and he had a sharp beam of light that would show dust in the room and that it would fall on things. And he even projected, according to the paper that I read recently, he even projected something through a microscope so that you could see these things moving on the microscope stage, which was pretty amazing in 1864. And he just took Pouchet apart. Pouchet did these fundamentally flawed experiments with a lot of mercury, and which was contaminated, and he had no idea of sterility. Then there was a big competition. Pasteur, every time he was challenged, would call for the Academy of Sciences, which he dominated through his pals and his mentors, to have a sort of big jury trial, and so that he demanded that, and a few months later, he and Pouchet were to have this competition where Pasteur would do his flasks and Pouchet would do his. And they show up in the lab of an old colleague, and they're supposed to do their experiment, each one with his own flasks, and Pasteur does his, but Pouchet, who'd recently been demolished at the Sorbonne, didn't do it. I mean, he just backed out. He wanted to establish all sorts of conditions, and Pasteur said, the jury said, forget it, and then he just sort of backed out. And the jury says, well, Louis, you really should try it with this hay medium. And Pasteur just had enough of this by now and better go on to other things, which would be silk moth diseases in a few years, under the wine and pasteurization and other stuff. And he just sort of said, forget it, I'm not doing it. And that was a mistake, because there was something there. And, France, they say in France, you can be on the left, you can be on the right, but you can't be anti-Pasteur. And I doubt that they teach this little weakness in Pasteur's arguments to French school children. And in fact, I can prove that because I was just in France and I told them this story. And they said, really? And so it was, in fact, Pouchet's medium had Bacillus subtilis in it, and it had spores. And these spores would, in fact, survive the boiling that Pouchet inflicted on them.
They came from the hay, right?
Exactly. And so when he went to the top of the glacier and he opened them, no spores came in, but air came in, and then that allowed them to grow. And so that was not settled until 12 or 15 years later, when Ferdinand Kohn, one of the first great German microbiologists, figured out how spores work. And then they could figure out that that was why Pouchet was finding these things.
So Pasteur was lucky that his loop-necked flask didn't have those spores.
Well, he never used. He only used yeast extract and meat extracts, and urine was a favorite one.
But you've seen his flask at the Pasteur Institute.
Oh, yes.
It's still there.
Still there. Many of them.
So the experiment's still going on.
The experiment is still going on.
This is a very slow-growing organism.
Well, it's very slow. But if he'd used Pouchet's medium, something would have grown.
So from this work that you've described of Pasteur's came the understanding that there were small or microorganisms that grew on their own, bacteria.
That's right.
Well, did we know there were bacteria and yeast, different kinds? Or?
Well, yeast are so much bigger. No, we didn't know about eukaryotes and prokaryotes.
Yeah.
But I mean, there were a number of other things that came in this period. One is the whole idea of anaerobic growth.
Okay.
Right, which was just anathema to people like Liebig. That's just impossible.
Yeah, the chemists. Right?
What about Metchnikoff?
Metchnikoff came later. Metchnikoff was one of the fathers of immunology, the founder of phagocytosis, and he showed up at the Pasteur Institute in the late 1880s, and Pasteur offered him a job, which he desperately needed at the time.
Exactly.
And he's a wonderful character, very strange guy, but he in fact founded this arm of immunology. Yeah. To go back to
I'm sorry, I didn't mean to
it's okay.
divert you.
To go back to this period in the 1850s, they do anaerobiosis, and they do the first infectious diseases of silk moths, which turned out to take 5 years. It was a disease in the south of France, was wiping out a major industry, and that was an infectious disease. One of the things was a bacterium, I think, and one was certainly a fungus that had been noticed previously. But Pasteur just figured out how, as with the beer and as with the beets, how to get broodstock that was free of this bacteria. And he taught the local farmers and how to use microscopes and so on. And eventually they solved that problem. But he also worked during the 1850s on wine And they were, he came from this little town called Arbois, and the wine of that region really was lousy, and it got sort of ropey and sour. And sure enough, there was a bacterium in there that wasn't supposed to be. And he figured out how to get rid of this by pasteurizing the stuff. By heating it. So they invented these great machines that were huge things, and they funnel the wine through it and heat it briefly until it killed the bacteria, and then it would develop.
So that's the origin of pasteurization.
Absolutely, yeah.
Which was later applied to milk.
Right. One of the great ironies of this age is milk is a ghastly infectious agent. It killed more kids until the first part of the 20th century than almost anything else. But Pasteur had 5 kids. 3 of them died of infectious disease, and at least 2 of them from typhoid, probably from milk, maybe from water. But, that was before Daddy invented pasteurization, so it was, there's a sort of ghastly irony to the whole thing.
Sure.
So, yeah.
So yesterday you told me of a Glasgow surgeon who learned something from Pasteur, which is very interesting.
Yeah.
He was a contemporary of Pasteur?
Yeah, he was maybe a few years younger. Joseph Lister, who was,
inventor of Listerine.
Well, I don't know if he invented Listerine.
I just threw that out because
somebody made a buck off his name.
To reveal my true ignorance.
Lister was another interesting guy who married the boss's daughter. And he was a Quaker. And he came from a family that was fairly well off. His father was a microscopist, an amateur microscopist, but good enough to be a member of the Royal Society. And so they were used to looking through microscopes. And when young Joseph, who was also something of a prodigy, wanted to go to university, he couldn't go to Oxford and Cambridge because until the 1870s, unless you were Church of England and accepted 32 articles of the Church of England, or at least said you did, you weren't allowed. And as far as I know, anyway, a lot of people sort of slipped in, I'm sure. And so there was, in the late 1820s, there was a University College London was founded by a bunch of dissenters, Quakers, Methodists, Jews, whatever. And it was founded on a certain principles, and the principles were the utilitarian philosopher Jeremy Bentham. And it was open to everybody. It was completely secular, and it was a sort of hard-working school, and it had a medical school, and that's where Lister went. Jeremy Bentham's skeleton, I should say, is still there. The rules of the university were, they dressed this skeleton in a frock coat and clothes, and it's still there in a cabinet in the main hall.
Did he have overdue library books?
No. He wanted to keep an eye on the faculty.
Okay.
And so that...
he wanted to bone up as an enemy.
Yeah, no, and they used to have they still have the head in some safe someplace, but the students from another one of the London colleges, King's College, like to steal the head and hold it for ransom. So now it's a wax head. But the rules of the university, as I read it from their website, say that whenever there's a faculty meeting, Bentham is sort of wheeled out. And it's marked in the minutes as Jeremy Bentham, very famous philosopher, present but not voting. Unless, of course, there's a tie vote, in which case Bentham votes for the motion, so there's never a tie vote in theory. We should try that. I'm sure that we have faculty around here who could pass, I think, for...
Yeah, sure.
No question.
Anyhow, so to go back to something more substantive, Lister becomes a surgeon. And he goes off to Edinburgh, which also had no religious requirements. That was the Scottish universities were far in advance of the English ones at that stage. And
Scotch will do that.
And he works for a guy named Sim, whose daughter marries. He does very well in surgery. He benefited from this really strange thing that I read about there. This was during the period of the Crimean War, 1850s, 1853 and 4. Someone who was supposed to give a series of lecture there had volunteered to go serve in Crimea and died of cholera there. Lister was asked to take over his lectures, and he did, and he became a very well-known sort of rising star in Edinburgh. And when a chair came open in Glasgow, he got it. And Glasgow was and is a different city from Edinburgh. It was heavily industrial. It was very shipbuilding industry, right? And it was just after by this time, it was just after the Civil War, and the Royal Navy had realized that wooden ships weren't going to do anymore. So they were building all these ironclads there. And the accident rate was crush injuries and broken limbs was just enormous, and they just built this brand new hospital. And Lister took this over in 1861, and the rate of infection was just awful, as it was in every other hospital in the United States and Europe. And for 3 years, Lister tried everything. He's a pretty inventive guy. And according to this Liebig fellow we've mentioned several times before, it was oxygen that caused this wound putrefaction or suppuration. And that if you kept the oxygen out, that wouldn't happen. But of course, since there were anaerobic bacteria, as Pasteur had discovered, that would happen. And you'd get gangrene with a clostridial infection or whatever. So that was ghastly. And that went on for a number of years, and Lister was on the verge of despair. He sort of had a tendency to depression. And he was desperate to do something, because he was a very sort of upstanding guy. And happily, he had a friend named Thomas Anderson, who was a chemist, who was a student of Liebig, and this all gets very incestuous, as it still does, right? Lister didn't read Pasteurian literature, but Anderson did. And one day, their labs, I looked this up on Google Earth. I figured out exactly where the labs were, and they were sort of quite close. And I figured out exactly where Lister had to walk to get home, and there's a reference in one of the students that they were walking home together. And it must be, the speculation is that during that walk, Anderson said to Lister, listen, you ought to read this Pasteur guy. And so Lister did, and I don't know. I mean, how long does it take for you to realize, oh my God, this is the answer? Probably just milliseconds. I don't know, we could ask Eric Kandel, I suppose. But that's what led to antiseptic treatments and antiseptic surgery. But Lister waited for more, crush injuries, broke. He realized that if you had a simple fracture where your bone didn't penetrate the skin, that was the sort of paradigm, then you would set a splint in a certain amount of time. You'd walk again. But if you had a compound fracture, then it was calamity. And the standard treatment for any compound fracture at that time was amputation, which was itself a disaster because the wound would get infected. And so he waited for people to come into his ward with broken legs, and the cases are all completely recorded with the names of the people and so on. Anderson also told him about carbolic acid or phenol. That was an antiseptic, which had been used to treat sewage, and he worked that out in great detail. He was Pasteur was a sort of only the high points thing. Lister was very, very meticulous sort of fellow. And he figured out that would kill these microorganisms that Pasteur told him about, and he absolutely believed in Pasteurian germ theory. He did that, and the first 11 cases, 10 of them survived, and the bones healed, and it took a long time. These people were in hospital for weeks and months. But he wiped out what was known as hospitalism in his ward, where the ward just smelled. It was, at that time, surgeons called it that good old surgical stink. And you can imagine. And he wiped that out. And his mentor was his father-in-law, Dr. Sim, or Mr. Sim in Britain. He essentially improved the health of his wards. Then this stuff improved. His techniques improved gradually over time, but the dissemination was the problem. Lister was mild-mannered as Pasteur was dominant. And but eventually by 1870, he convinced a bunch of German surgeons and a few French ones, but very few, and some Scots, but very few of the British surgeons, the English surgeons.
Someone should name some kind of antiseptic product after him.
Yeah.
So where does Semmelweis fit into all this?
Okay. Semmelweis is before this. Okay. And Semmelweis is 1846-47 in Vienna. There's a very good book on this, or article on this by Sherwin Newland, the Yale surgeon and writer. And Semmelweis was this interesting guy who was a Hungarian. It was then all the Austro-Hungarian Empire. And so Hungary was part of the feeder countries for Viennese medicine. So Hungarians would come to the University of Vienna, which was a sort of mecca of medicine at that time, and very scientific. It was, Freud wasn't there till much later.
No, but it was a famous place because of him, too.
Yeah, well, it has a very checkered history, that medical school, but that's another story.
I thought that was another country.
This Austrian medical school. In any case, So there were very famous docs there, and they were taught a very scientific form of medicine, which involved a lot of autopsies, and starting in about 1830 or something. And so when women came to the hospital to deliver, there were 2 wards. You imagine a long corridor, and at the top there's a T, another corridor going in the form of a T, and on the right was a delivery ward, which was run by medical students and docs, and on the left it was all midwives, under the control of a physician, but essentially babies were delivered by midwives. And the rate of puerperal fever, that is strep infections of the uterus, would just spread throughout the body, was enormous and the statistics exist, in the doc's ward, but not in the midwife's ward. And Semmelweis, being a surgeon, an OB-GYN guy, noticed this. And what's more, he noticed that the medical students would, once a woman died, they would dissect the body, find that there were vast abscesses everywhere, and then without really cleaning up or changing their coats or anything, come back and deliver more babies. The women would get puerperal fever and die again. And, this had been a problem that wasn't new. Other people had solved this problem previously, but it was a question in Ireland and various places. People had noticed this, and even our very own Oliver Wendell Holmes Sr., the father of the Supreme Court Justice, had figured out how to avoid this 5 years before Semmelweis. But it wasn't promulgated throughout the medical community. In fact, when they published this stuff, both Holmes and Semmelweis were attacked because, God forbid, that I, a great obstetrician, was killing women.
2 people, that's right.
Yeah. So Semmelweis, unfortunately, Holmes was a writer, and he went off to do that, and he basically gave up after being attacked.
Yep.
He founded the Atlantic Monthly, as a matter of fact. Semmelweis went a little crazy. I mean, he became very paranoid. And according to Sherwin Nuland, he may have had some early onset Alzheimer's disease, but he became very paranoid, and he refused to write anything down. So it wasn't until 1865, almost 25 years later, that he writes this book, which is basically not a scientific book, but a screed that attacks the entire obstetrical community of Europe, especially of Germany and Austria. And, it had lots of tables in it, but it was very accusatory. And he very shortly thereafter died, and the whole thing just sort of sank.
Yeah.
And it sank into oblivion for another 20 or 30 years. And in fact, it was Pasteur who first isolated, at least was one of the first, streptococcus from the blood of a woman with puerperal fever. And I just, I saw that paper just yesterday.
So the spread of the information that these people discovered was difficult in itself.
Yeah, and we owe much of that to Lister.
Lister was able to do it. He was meticulous, and his nature was such, he wasn't antagonistic, and that probably helped as well.
But he became a hero to his students, and they gradually spread through
that's
all
good.
of the European medical centers. And he was very good at languages. He spoke German, he spoke French, even Dutch. And he would by the 1870s, whenever he toured Europe, it was a sort of triumphal process, because he had ended this dreadful scourge. I mean, up to a certain point, when a hospital became infected, its woodwork, its bathrooms, with strep and gangrene, there wasn't any solution. You had to just tear the thing down. And after Listerian sterilization, which was difficult to apply, and was very hard on your hands. There were no gloves at this stage. It was spreading phenol on your hands. Then that became unnecessary. And at one point, Lister operates on the Queen, who had this ghastly abscess in her armpit, and the abscess gets cured. It doesn't get infected, and that gives you street cred.
Sure.
That's good.
Strokes of luck. You need them.
What about Coke?
Coke is later.
Coke is a little bit.
But I think we don't have time for Coke.
We don't have time for Coke? How about Diet Coke?
I've been wanting beer and wine from this conversation.
Yes, right.
I think we should save Coke for another time. But we'll have you back to talk about Coke. But let's summarize. So far we have the microorganism, the theory of microbial growth.
Starting it.
He sees them. Pasteur shows it grows and ferments. And then Lister says that these things that Pasteur have discovered are are causing my patients to die,
Right.
so I have to get rid of them.
That's right.
But there's
and he has a means to do it.
And he has a means to do it, which is promulgated worldwide eventually, which makes surgery much more
it's
successful.
the promulgation that's the important fact.
Right.
But no one yet has understood disease and microbial associations, right?
That's correct.
And
Not specific bacteria, and that's where Koch
That's where it
comes
comes
in.
in.
That's the story of anthrax.
So we'll revisit that. We'll have
And
you
then
back.
Jon Snow and those kinds of
Will you
people
come
coming
back
too,
and
I guess.
revisit
Absolutely,
this?
anytime.
Oh, we would love it, Rich.
All right, because now we'd like to do a few emails and then close it up on TWiV. We have an email from Ted, who is an MD. Just got today. Could you include a segment of basic virology with each episode? I much enjoy the show. Thanks for your efforts. So I put that in just to tell everyone we will start doing this. We'll have a short segment on basic virology, and then perhaps we'll have a web resource to accompany it with illustrations. Right, Dick?
We'd use somebody's textbook for that, I presume.
We could. Everett writes. So Everett sent us a ProMed Mail posting from actually February, which was a case in Brazil of an individual who had rabies and recovered. So this is someone who was not immunized.
Very unusual.
And this is only the second person ever to survive, a non-immunized person. And they use the Wisconsin technique, which is to put the person in a coma. Basically, they cool them and they put them in a coma. And this worked for a patient in Wisconsin. And apparently in this Brazilian case, there's this physician from Brazil. Our patient is alive. He was discharged from the critical care unit last Wednesday. He's conscious with motor limitations. He is speaking with a good cognitive function. So maybe this is the second example of the Wisconsin protocol as it is now come to be described. We have an email from Len who said, you might be interested in this paper. Even though it's about a bacteriologist, it's the 50th anniversary copy of the paper that showed that DNA was the material that contained the genetic code. And I bring it up for several reasons. First, it seems like I recall several episodes ago you guys raised the question of when DNA was discovered to contain genetic material. Second, the senior writer Avery was involved in work on the Spanish flu during the epidemic of 1918. See Barry's book, The Great Influenza. And it's worth noting that Avery was involved because no one knew at the time that influenza was a virus. Most scientists thought it was a bacterium, even naming one influenzae, if I recall correctly. So it shows both how science... Haemophilus influenzae. It shows how science sometimes jumps to the wrong conclusions and how it is usually self-correcting.
Yes.
Sometimes it takes a long time, unfortunately.
This is true.
Finally, you guys were talking about Nobel winners an episode or so ago, and Avery is often said to be the most deserving person
That's right.
never to win a Nobel Prize for this very discovery.
Well, he wasn't the only one that did it, though. McLeod was involved in
Well,
it.
it was Avery, McCarty, and McLeod, 1944.
Three of them.
That's right. Why didn't they get a Nobel Prize? So maybe they died before.
Search me. No,
they lived a long time.
Yeah.
They did.
The Nobel Committee has had some bizarre oversights over the years, and that's definitely one of them.
Yeah, they've also given it to people who found stuff that was wrong.
This is all true.
Yes.
Anyway, it's an interesting bit of research history, and I thought that even if you don't mention it on TWiV, you would find it worth a look. So we're mentioning it because it is worth it. And he sent us the anniversary copy of the Journal of Experimental Medicine paper.
Nice.
With photos and commentary. So we'll post a link to that. Thank you, Len. And lastly, a email from Zachary, who you might know, Rich.
Oh, yes, my son.
We had a little conversation, and I had told him I was afraid that it was getting too technical here on TWiV. And he said, don't worry about being too technical, but maybe have a few episodes of a more introductory nature or have a periodic questions show. Astronomy Cast does this, where you ask folks to send you questions. You can even actually have people send you questions in audio so you can put them in the podcast. And in fact, we started asking for audio questions. That's a great idea. Eventually, people will start sending them in, but it gets the audience more involved. We hear their voices and so forth.
From out of the mouth of babes.
That's a great idea.
He's not a babe anymore.
All of our children will remain that way. I'm sorry.
He has babes.
Oh, wow. Grandfathers.
And lastly on TWiV, it's time for our science picks of the week. So, gentlemen, every week we pick something in TWiV to do with science that you like, a book, a website, a museum, anything, a TV show, and we'll give you a chance to think about what you might like, and you as well, Dick.
Well, I already sent you those.
Oh, you
the
sent
origins of
the origins of
diseases.
infectious diseases. Those
That's right.
papers that you sent.
3
Very
of them.
well. 3 papers from Dick, which we will post on the website. They're about the origins of infectious diseases, which you happen to like.
Which the reason why I mentioned all 3 of them is because they all identify viruses as the most recent emergence of infections into humans. So, since this is a show about virology, I thought this would be a
Okay.
good segue.
I have one.
Go ahead, Rich.
I just read a novel by a New York writer named Annie Roiphe, Roiphe. It's called An Imperfect Lens, and it's about the hunt for the bacterium that causes cholera. And it's the story of a team sent by Pasteur to Egypt,
Wow.
one of whose members was one of his students who was one of the people who came out with the rabies vaccine, a kid named TWiV, who was 28. And while in Alexandria, he gets cholera and he dies. Attended by Koch, who was also there.
My goodness.
And it's of course, there's a love angle and everything in this novel, but it really gives you the feeling of the disease and the city at the time, which was in 1883, I believe.
Is that a historical novel? Or
Yeah,
is that
yeah. It's a lot of
It's
fiction.
not a
but-
biography or anything.
No. It's a
Okay.
historical.
It uses real events
it's
as a background.
It's a very good read, and
Oh, that's fantastic.
it makes you scared as hell of cholera.
You should be.
Very
Yeah.
good. The Imperfect Lens by Annie Roiphe, is that?
Roiphe, yeah.
Roiphe, thanks. That's a great pick. Alan, what have you got for us?
I have a Firefox plugin that I have looked at this a couple of times, and they just came out with version 2.0 as a beta release. It's a plugin called Zotero, and this is it's a way of organizing bibliographic citations and notes and files and PubMed citations and PDFs that a lot of people use either EndNote for this, or I believe you've been using Papers on the Mac.
Correct,
right?
yes.
So those are ways of organizing these things in the desktop environment. Zotero is an actual Firefox plugin. It does all of this in the browser. It stores its files in a directory structure that it sets up, kind of like Papers. But if you go to PubMed, you do a search, and you get an icon in the address bar in Firefox. You click on that icon, and it will import all of those citations and their abstracts directly into Zotero. You then have reference to those, and in fact, it takes snapshots of the page and stores them locally, so that when you're offline, you're someplace else with your laptop, you can look back at them and read the abstracts. If you've downloaded the PDFs, that's also linked in there. So it stores all of this stuff and does it all within a browser window, which I find very convenient. Other people may prefer a desktop type application like Papers, but one of the other advantages of doing this through Firefox is if you sign up for a free account, this is free software, it's open source, and there's the site is zotero.org. They also have a service where you can synchronize your Zotero links to your account on their website, and then you go to your other computer, you synchronize, and you get all the stuff that you were researching on your desktop computer shows up on your notebook computer, courtesy of the website. And you can even synchronize, if you have your own web dev server, you can even synchronize the files across by that. So it's sort of cloud computing for researchers.
I like the idea because I'm often doing things in a web browser, and I need to find articles, and to go to another app is kind of inconvenient sometimes. I have to give it a try. I like the tagline at their website, Zotero, goodbye 3x5 cards. Hello,
Yes.
Zotero. That's great. And it's open source, which is great. Very good. Thanks for that pick. My pick is a website called eScience News, and this is a automated news engine for science, basically. And there's no person behind this. It's powered by the Eureka News Engine, a fully automated artificial intelligence. Its purpose is to ensure that you have access to the very latest science breakthroughs. To achieve this, it surfs the web, gathers science news from all major science news sources. It computes relationships between science articles and news found on the web using a vector space model and hierarchical clustering.
What else?
Then,
Of course. I had 2 of those for dinner last night.
It then automatically determines in which category each news item belongs using a naive Bayes classifier. Finally, it examines multiple parameters such as timeliness, rate of appearance on the web, number of sources reporting the news, etc. for each news group. The result is an E-score, which represents the relative importance of a news item. It was built and maintained by Michael, who's a PhD student in retrovirology and bioinformatics. It's really amazing. It automatically scans, and you can have an RSS feed so that it pulls up all the good stories, and it categorizes them. If you want to just look at biology and medicine, for example, you could just focus on that. And it's totally automatic. It's wonderful.
Wow.
eScience News.
We've come a long way in the last 10 years.
Yeah, I don't have any students who could do that, although maybe Alan in your day, you could have done something, but I didn't give you any free time, so.
Yeah, if I'd been a bit sharper on the computing side, but this is definitely beyond me.
This is a good programmer, but if you're a scientist and you know what is needed and you can also program, it is beautiful. Because I know what I would like to have, but I can't program. And to have the both together, I think, is fabulous. So you're doing a great job, Michael. So that's my pick, eScience News. That should wrap up another TWiV, gentlemen. Thank you for joining us. Rich, thanks for coming.
Oh, you're welcome.
Do you have a website that people can reach you?
No, I don't.
You have an old one at Anatomy and Cell Biology.
Yeah, but that was one back in the days when I did experiments. I have nothing on this sort of
You
thing.
should do something that reflects your interest in history.
Yeah, perhaps I should.
And
maybe.
When you do, we'll...
That's what Young Zachary does, his websites.
Very good.
So.
All right, thanks for joining us. Alan, thanks for joining us.
Always a pleasure.
Alan on Twitter is Alan Dove, and you're at dovedocs.org.
.com.
I always get it wrong. dovedocs.com. Dick, glad to see that you weren't in Qatar.
Pleasure to be here still. But
Dick
maybe next week I will be.
Dick is at trichinella.org.
Yep.
What was the other site you wanted to...
Medicalecology.org.
Okay. We'll put that on the website as well, medicalecology.org. What do you do at Medical Ecology?
We point out the relationship between a damaged environment and a health risk.
Excellent. Maybe we should talk about that sometime on TWiV.
All levels. Yeah, we've got a lot of infectious disease stuff on it.
All right, great. Medicalecology.org. And you can follow TWiV at PROFERR on Twitter. We have a website, twiv.tv, where we put show notes for all the shows. And please send us your questions and comments.
Absolutely.
Twiv at twiv.tv. And do send in an audio file in MP3 format. We'd like to hear what you
Or your corrections to all this misinformation.
Absolutely. Corrections as well. Some of you have come over from the Twit network, and you've told us a bit about yourselves. Tell us what you do. I'm interested to hear what people are interested in and how they've found us and so forth. So any comment is welcome. So twiv at twiv.tv. You've been listening to This Week in Virology, the podcast all about viruses, the kind that may or may not make you sick, not the computer kind. We'll be back next week. Another TWiV is viral.